Alrighty, 9.4, formulas and further applications. This will be the last section of this chapter. We're going to talk about formulas, which we've talked about a few times before this year, but now we're going to throw in the square root property. That's pretty much all it is. So recall, a formula is a mathematical sentence, right? A formula is a mathematical sentence that makes sense in the real world. Do you need to know the formula to be able to rearrange it? No. But certain formulas like Pythagorean theorem, distance formula, there's two versions of that. There's distance equal to rate times time, and there's also the one that goes with Pythagorean theorem. There's a whole bunch of formulas that you probably should know, and you probably do know. So let's start by rearranging some formulas that maybe you don't know. We're going to just rearrange them. Solve each formula for the given variable. Include plus or minus answer if necessary. Okay, so all of those rules still apply. Those variables are not special. They think they're special, but they're not. They're just numbers we don't know yet. So all of the rules about square root property still apply. Excuse me. Okay, so here I have W equals K capital FR over V squared. I want to solve it for V. Well, first off, it's irrational, right? So I have K FR over V squared. I've got the variable in question in the denominator. That's a problem. So let me multiply by it to get rid of it, or to move it to the other side and actually put it in the numerator. Excuse me, sorry. V squared W equals KFR. Now I need to divide by W to get that W out of the way. Go as far away from the variable as I can. V squared is equal to KFR over W. And then I take the square root of both sides. So V is equal to plus or minus, that still applies here, KFR over W. I have solved for V. Sweet. I'll go back to my old colors so I can swear. Let's do the next one. Solve D is equal to the square root of 4A over pi for A. Well, to begin, A is stuck under the radical, so let's get rid of that radical first. That's really kind of the farthest thing from the variable. So D, that's a horrible D. Let's try that again. D is equal to square root of 4A over pi, right? So I'm going to square both sides. Now when I square, that's the power property of equality. That doesn't mean I have to add a plus or minus. So I just end up with D squared is equal to 4A over pi. Next, I'll start moving things away from pi. I think I'll multiply, or from A, I'll move pi over. So I get pi D squared is equal to 4A. Then I can divide by 4, and I end up with pi D squared over 4 is equal to A. So these I'm just solving. I'm moving things away from the variable in question. Same dealio as last time, right? I'm going to skip C for just a moment, and I'm going to jump down to D, just because it's very similar to B. We'll go back to C in a sec. So let's figure this one out. This is L. So I'm solving L is equal to KD to the 4th over H squared for H. KD to the 4th over H squared. Again, I have the variable I want in the denominator. That makes this irrational, which is not what I want. So I'll move that guy over. Cancel. I end up getting H squared L is equal to KD to the 4th. Divide by L, right? End up getting H squared is equal to KD to the 4th over L. Last but not least, square root both sides, you get H is equal to, now I must have a plus or minus because I took the square root, I went down, KD to the 4th over L. And that would be my final answer. Yes, the right hand side is not very pretty, but it is solved for H. That's what I want. Okay, let's go back to this one for a sec. S is equal to 2t squared plus kt, solve it for t. Now the problem here is I've got t occurring in two places, and one of them is a quadratic and one of them is a single. So no matter how many times I try to use distribution property or to put t on one side, it's just not going to work in a classic rearranging sense. Okay? However, what if I did this instead? If I move s over, that's an s, I have 0 equals 2t squared plus kt minus s. That looks very familiar. And there's a reason this one is specifically waiting until, I waited until the very, very end to give you this problem. It's because it's quadratic. It's a quadratic equation. So I'm going to plug this into the quadratic formula where t is x. So t is equal to minus b, well in this case, b is k, so minus k, plus or minus the square root of b squared, so k squared, minus 4, let's see, a was 2, 4 times 2, times c, in other words, c is a negative s, all over 2 times a, which is 2. Simplify that just a little bit. You get negative k plus or minus the square root of k squared minus plus 8s all over 4. If we simplify that, 2 negatives become positive, that becomes an 8, that becomes a 4, and that's pretty much as far as we can solve it for. But we did. We solved it for t equals this, right? So that's why we waited until now, until pull this formula out. You can use any trick you need in the book to get you the variable in question by itself, whether it's standard rearranging, or it's square properties, or it's quadratic properties, right? This whole chapter is about the quadratic properties. So use those tricks to help you figure out those formulas. Last formula we'll do actually goes back to pretty much rearranging. I have f is equal to k over square root of d. That is, we want us to solve it for d. Again, it starts off rational, which is a problem. I don't want things in the denominator, so I'll multiply by the square root of d to get it to the other side. Whole thing, I'm not dealing with the square root part yet, I'm just dealing with the rational part. So I have the square root of d is equal to, or times f is equal to k, because those two cancel. Now I'll move the f over, because that's farther away than the square root. And I end up with square root of d is equal to k over f. K over f. And then finally, take the square of both sides. I end up with d is equal to either k over f squared, or if you prefer, k squared over f squared. Either one of those is perfectly acceptable. Alright, so that's rearranging formulas. That was very quick because we've done this like 4 times now. There's only a tiny little bit of new stuff. And then the other half of this section is about word problems. So if you have any questions on that, feel free to on the formulas, feel free to email me. Otherwise, I'm going to head into the word problems now. Our first word problem is about Pythagorean theorem again. So let's see if we can use the Pythagorean theorem or distance formula, depending on your preference, to solve this problem. Two cars left the intersection at the same time. One heading north, the other heading west. Sometime later, they were exactly 100 miles apart. The car heading north had gone some 20 miles farther than the car heading west. How far had each car traveled? Alright, so let's take a look at this. Here's our intersection. One car is going north, one car is going west, towards California, right? And that's horrible west line, so let's draw that again. There we go. And then sometime later, I know I'm getting into the problem, that's okay, they were 100 miles apart. Alright, so we can see this is going to be a right triangle problem. The other piece of information they give us, the car heading north, so this car right here, had gone 20 miles farther than the car heading west. Alright, so I know less about the car heading west, so I'm going to make that x. But what I do know is that the car heading north is 20 miles more than the car heading west, right? So I know it's 20 plus however far the car heading west is, therefore it's 20 plus x. Alrighty, now I can use my theorem. A squared plus b squared is equal to c squared. So x squared plus, and I must put this in parentheses, x plus 20 or 20 plus x squared is equal to 100 squared. And I've translated. Let's go ahead and solve. So I have x squared plus x plus 20, I'll do over here, plus 20 times x plus 20. It's not x squared plus 400. It's x squared plus 20x, and 20x makes 40x plus 400. So I have x squared plus 40x plus 400. And that is equal to 100 squared, I believe, is 10,000. Yep, 10,000. Alrighty, combine some like terms. I've got 2x squared plus 40x plus 400 is equal to 10,000. It's looking quadratic, but I can't do anything yet with that 10,000 on that side, so I'll subtract it over. And I get 2x squared plus 40x minus, so 400 minus 10,000 is negative 96,000. Nope, negative 9,600. And that's now equal to 0. Everything's even, so why don't I make my life easier and divide by 2? I get x squared is plus 20x minus 4,800 is equal to 0. Okay, that's a little easier to solve. Okay, two things that are going to multiply to negative 4,800 and add to 20. Sounds an awful lot like negative 48 and adds to 2. I think 80 and 60. 80 times 60 is going to be 4,800. So in order to get a negative, then that means 60 had to be the negative. So I get x plus 80, x minus 60 is equal to 0. So either x is equal to negative 80 or x is equal to 60. That's our solution. Which one of these makes sense in the context of the problem, though? Let's translate back. Let's see, what was the question? How far did each travel? If x is supposed to be how far our west car traveled, then only 60 makes sense, right? So the west car traveled 60 miles, and then the north car is going to travel 20 more than that, or 80 miles. And we have our final answer. So Pythagorean theorem problems, you just got to set up the picture. The picture is very helpful when it comes to Pythagorean theorem problems. And then set up the quadratic, solve the quadratic. You can use quadratic formula from here, totally fine. But as you saw, factoring took like 3 steps. And then you translate back to get your answer. Make sure you always translate back, right? Negative 80 was not an answer here. Alright, let's try another one. This one's probably one of my favorite problems. A regular reflecting pool in a park is about just 20 feet by 300 feet, 20 feet wide by 300 feet long. The park gardener wants to plant a strip of grass around the pool. She has enough for seeds of she has enough seed for 336 feet squared. How wide will the strip be? Well, let's draw ourselves a picture. So I've got this pool, right? It's 20 by 30. And we want to put a strip around it of some grass. So I'm going to put a strip around it of some grass, right? So I've got 2 rectangles going on here. I've got the inside rectangle, we'll make that one red. I've got the outside rectangle, we'll make that one blue. So two different rectangles going on here. And then the strip itself is going to be all this space in between the 2 rectangles. So the area of the strip, this part right here, right, is going to be, I guess I should use green. So the area of the strip is going to be the area of the blue one. So the area of the blue triangle, we'll call it the outside rectangle, AO. And then we're going to take out the area of the inside, right? Because she's not going to plant grass in the water. She's just going to plant it on the outside. So it's going to be the entire blue area, take away this red area in the middle. That's going to be our equation for this area problem. Now let's see if we can figure out some things to plug in. What else do I know about area? Well, I know that area in general is equal to length times width, right? The length times width of the red one is going to be what they told me, 20 by 30. So I'm going to write that over here. 20 by 30. 20 times 30. The area of the strip, she told me, or she said she has enough seed for 336 square feet. So that's pretty good. The only problem is I don't know the area of the outside, right? If I knew the area of the outside, I could easily just subtract the two and figure this out. Problem is I don't know that. But let's take a look at this geometrically. This part I do know, right? This much of the outside strip is going to be that same 30 inches. It's going to be that same 30 inches. And then over here on the edge, this edge part right here is going to be the same as the width around the grass. So we can call it x and another x. So the top of this area of this rectangle is going to be 2 x's and 30. In other words, the length is going to be 2x and 30. We can come up with the same kind of situation for the width, right? I know this area here in the middle is going to be 20. And then if it's the same width all the way around, I know that this width is also going to be x and x. Or in other words, 2x's and 20 gives me my width. Those two multiplied together gives me my area of the outside rectangle. Alrighty. And I have translated. Now I can simplify. So I have 336 is equal to, let's multiply these two guys, 4x squared plus 40x plus 60x plus 600. And then over here I have a minus 600. Simplify some terms. Oops, 600. These two go away. I can combine those two guys to 100. So I have 336 is equal to 4x squared plus 100x. Almost quadratic. As soon as I move this guy over, I get 0 is equal to 4x squared plus 100x minus 336, and now it is quadratic. Everything here is divisible by 4, so I can divide everything by 4, maybe make my life easier. And I end up with 0 is equal to x squared plus 25 minus 84. And now I can solve this guy. So I can choose any way I want. I think I'll use quadratic formula. X is equal to minus b plus or minus the square root b squared minus 4ac negative 84 all over 2a. Negative 25 plus or minus, let's see, 25 is 625 minus 4 times 84 leads me to a 289. The square root of 289 is 17. Plus or minus 17 over 2. Negative 25 minus 17, that's going to be negative 42 over 2, so 21. Split these. I'll do this first one over here. So negative 25 minus 17 over 2 is going to be 21. Negative 25 plus 17 over 2 is negative 4. So my answers are negative 4 and 21. Negative 4 and 21. Which one of those actually makes sense as a width for a strip? Wait a minute. I think something went wrong in my quadratic formula. Hold on one second. Oh, it should have been plus. My apologies. Not minus. Not minus. So that would be 625 plus 4 times 84. 691, square root of that would be 31. My apologies. This should be a 31, not a 17. 31. We'll just erase all this. See, even math teachers make mistakes too. We drop negatives. Doesn't mean we should, but we do, because we're human. Okay, so this is a minus, so that actually ends up being a plus 625, and you take the square root of that, you get 31, not 17. So negative 25 plus 31 is 6, divided by 2 is 3. So negative 25 plus 31 divided by 2 equals 3. Negative 25 minus 31 is negative 56, divided by 2 is negative 28. So negative 56 minus 31 over 2 is negative 38. And which one of those makes sense? That one. Right, so we're talking about an area, or how wide the strip will be, right? How wide it is has to be a positive number. So we get 3, and she says feet, so 3 feet wide. All right, so that's an area problem. It really comes down to this part right here. You have to know this kind of take a section out thinking, and after that it's just a straight up quadratic formula problem. Let's do 2 more. So the last thing we're going to talk about is treating these guys as functions. Remember, we can always treat something as a function as long as it is 1 to 1. And all we'd have to do is replace the 0 part with f of x, right? So as long as a does not equal 0, it's a quadratic. As long as you don't have 2 inputs giving out 2 outputs, you'll be fine. And this one, if you use real numbers, nothing is a problem. So let's see how we can use some of these. There's 2 different types we can use in real life. Let's use these quadratic functions as a model. If an object is projected upward from the top of a 144-foot building at 112 feet per second, its position in feet above the ground is given by s of t is equal to negative 16t squared plus 112t plus 144, where t is the time in seconds after it was projected. When does the object hit the ground? Okay, so we've done stuff like this before, right? Here is s of t, that's what they're telling us its position, right? When the position is defined by this, where t is the time in seconds. So that's important to remember what these variables mean. As a model, they mean things in real life. When does the object hit the ground? The ground would be at 0 height, right? So 0 feet. Question is that a position or a time? Which one am I going to plug 0 in for? I'm going to plug it in for the position. So the whole s of t side becomes 0. It's equal to negative 16t squared plus 112t plus 144. And we can solve quadratic formula. Just checking something real fast. My goodness. Okay, yes, so 16 does divide into this whole equation, so I'm going to divide by negative 16 to everything. Because why not? Make my life easier. And also do this side. So 0 is equal to t squared. 112 divided by 6 is, 112 divided by 16 by negative 16 gives me a negative 7. T, and then 144 divided by negative 16 is a negative 9. Alright, that's so much easier than working with 112 and 144. So always see if you can take out a GCF. GCFs are really nice. Take them out, divide them out. Let's see, 2 things that multiply to negative 9 and add to 7. There's 3 and 3. No, it doesn't look like it. So let's use our quadratic formula. It's not going to be a real rational solution. It's going to be a real irrational solution. Or maybe not even real at all. So t is equal to minus b plus or minus the square root of b squared minus 4. A is 1, c is negative 9, all over 2 times 1. And up here, so 7 plus or minus square root. 7 squared would be 49, minus 4 times 9, negative 9 would be negative 36, so plus 36 over 2. That's 7 plus or minus, let's see, 49 plus 36 is 85. So I was right, not a perfect square, not going to be some rational numbers, right? Square root of 85. Let's see, square root of 80. Since we're doing a time problem and we actually wanted a decimal to kind of see where we're actually sitting at time, let's just go ahead and take the square root of 85. We get plus or minus 9.22. So 7 plus or minus 9.22 over 2. 7 plus 9.22 over 2 is going to equal... Nope. 9.22 divided by 2. 8.11. Well, on the other one, 7 minus 9.22 over 2. 7 minus 9.22. Divided by 2 is going to be a negative 1.11. Alright, we've solved this quadratic equation for our two answers. Which one actually makes sense as a time? That would be the positive one, right? There's no such thing as negative 1 seconds. So it's going to take 8.11 seconds to hit the ground. And that's our final answer. Alright, let's try one more of those. The number of publicly traded companies filing for bankruptcy was high in the early 1990s due to economic recession. The number then declined during the mid-1990s and then increased again. The quadratic function defined by f of x equals 3.37x squared minus 28.6x plus 133 approximates the number of companies bankruptcy filing during the years 1990 to 2001, where x is the number of years since 1990. Use the model to approximate the number of filings, I think it should be filings, whatever, in 1995. Okay, so in 1995, so you'll see this a lot. You'll see people try to create equations where x is something, the number of years since this and that, and you just got to take one extra step. So the number of years since 1990 to get to 1995 would be 5 years. So here x equals 5. So I know the x, right? I know the year. Here they just want me to evaluate f of 5. So let's do that. Let's evaluate f of 5. I have 3.37 times 5 squared minus 28.6 x, oops, not x, right, because we're substituting in 5, plus 133. We can simplify this down. 3.37 times 25 minus 28.6 times 5 plus 133. PEMDAS says I should start with exponents first, right? Now I'll do the multiplications. 3.37 times 25 would be 84.25 minus 28.6 times 5. It's going to be 143 plus that constant. And then we subtract them all. And we get a whopping 74.25 companies filing for bankruptcy. That's a lot of companies. That sucks. I almost lost some units on it. Companies, call it a day. Alright, so the whole point of that problem was to show when you needed to plug in, right? So it's important to remember how your function works. Are you asking to find a time, or are you asking to find a number of bankruptcies, right? So it's very important to know the pieces of your function. Let's do this last one and see, in what year did the number of filings reach 150? So now we know things about the filings. We know F is equal to 150. So let's plug in 150. Oops. Let's write that better. So I know F is equal to 150 filings. In other words, I know the left-hand side of the equation is equal to 150, right? So this is different. I'm asked now, when did something happen? X is the when, right? X is the when. So let's plug that in, and we will see when we reached 150. Okay, gotta subtract this to the other side. I get 0 is equal to 3.37x squared minus 28.6. The only place that's going to be subtracted is from the 133. When we get negative 17. I'm not going to try and factor this or use complete the square. I'm just going to use quadratic formula. So x is equal to minus b is going to be a positive 28.6 plus or minus the square root 28.6 squared negative, okay, hold on. Let's just write this as we've been. So x is equal to minus a negative 28.6 plus or minus the square root of negative 28.6 squared minus 4 times, let's see, a was 3.37 and c is now negative 17 all over 2 times 3.37. Okay, we'll simplify that down a little bit. 28.6 plus or minus 28.6 squared, take away 4 times 3.37 times negative 17, ends us getting 1042.12, the square root of that was 32.36. So all I've done is found this discriminant right here. I put this whole thing right here into my calculator, essentially. That helped me find that, and that is now over 2 times 3.37 is 6.74. That's what I thought. Cool. Now I've got two answers. I can separate them out. I've got, let's go down here, 28.6 plus 32.36 over 6.74. And I've got 28.6 minus 32.36 over 6.74. Big comma there. Here this one ends up being excuse me. It's 52.26. Hold on, something went wrong. That's all good. Let's try solving that again. I think I messed up my discriminant. I do apologize. So let's go back a little bit. Solve these ones again. Good thing this is just a supplement video. It's okay, I can do this for real in class. Okay, so 28.6 squared. Square root 28.6 squared. You should. Squared minus 4 times 3.37 times negative 17. It's 32.25. Interesting. So we have 28.6 plus or minus 32.36 over 2a, so 6.74. All right, 28.6 plus 32.536 divided by 6.74. Ah, that's what it was. At the very end, I just entered in too many numbers. Okay, so the plus version would be 9 point, we'll round it to 9.0. The minus version is going to be negative 0.56. Sorry about that, didn't mean to confuse everyone. Which one of these would make sense as an answer for the years? Years would probably be 9. So 9 years. So x equals 9. 9 years from 1990 would be the answer of 1999. That is when we had 150 bankruptcy filings. Alright, so hopefully that cleared up some thoughts about formulas and the different kind of word problems. If you have any other questions, feel free to email me. Otherwise, I will see you next video, if there is one.